So let's talk about the lungs and breathing, the mechanism of breathing. Do not think of the lungs as two big sacs or balloons. If you cut one in half, it's more like a sponge. That is because of the millions of alveoli that are microscopic sacs that actually make up each lung.
You can see this on page 755 of your textbook.
Turn there and look at that. These millions of small sacs, called alveoli, create a tremendous surface area for gas exchange. A normal pair of lungs has the surface area of an entire tennis court if you flattened out each of those little alveoli. Amazing. Of course, if you smoke, you may be getting by with half a tennis court. And if you get lung cancer, you may end up with a lot less than that. If you smoke, quit today, and your lungs will begin their journey towards normalcy. You too can play with a full tennis court. What cavity do the lungs lie in? Did I hear you say thoracic? You're so smart. But what membrane surrounds the lungs? They are the pleural membranes, and as usual, they come in the parietal and visceral flavors with fluid in between. So the pleural membrane has a parietal pleura and a visceral pleura, and there's fluid in between. We will review the importance of this structure in lecture, during our lecture time. The right lung has 3 lobes and is larger than the left lung. The left lung has 2 lobes. It is smaller because the heart lies in the left quadrant and creates a cardiac notch or cardiac impression, which takes up some of the space of the left lung. So, are you exhausted by all this respiratory stuff yet? Well, take a deep breath. Now, let it out. Yeah, take a deep breath, really. And now, let it out. What muscle did you use? Take another deep breath, a big breath. More. Hold it. Now, let it out. Can you feel your muscles working? Now that I've got you breathing, let's talk about breathing. We basically have 3 kinds of breathing.
Turn to page 761 of your textbook and follow along.
There are 3 kinds of breathing, not listed there. They are 1. Normal everyday breathing, 2. Forced inspiration, and 3. Forced expiration, or blowing out the birthday candles. If you had to name one muscle responsible for breathing, the most important would be the diaphragm. Now don't confuse this with the birth control device. Those who make this mistake will look at their music coach very strangely when they are told to sing from the diaphragm. Although the diaphragm is important for normal breathing, other muscles are involved, especially when a greater than normal breathing takes place, such as forced inspiration or expiration. Turn to the next page to see what these muscles are. As you look at this mechanism, remind yourself about the fact that muscles can only do one thing, that is contract. They cannot push. So how do you push air out of your lungs during forced exhalation? Okay, try this. Take a deep breath and then push it all out. Push, keep pushing, push it all out. Push. Okay, now that you've had that baby, you can relax and breathe regularly again. Did you feel that? Did you feel what happens when you push out? What muscles are involved? If not, try it again. Push the air out. Push it all out. Feel your abdominal muscles tighten as you push out that last breath of air. So, normal breathing involves the diaphragm and intercostal muscles. Forced inspiration, that is taking a deep breath, involves the diaphragm, the external intercostals, and the scalene muscles. And on a really deep breath, you involve the sternocleidomastoids and the pectoralis minor. Feel that as you take a really deep breath. Look at that in the diagram in the book. Forced expiration, blowing out the birthday candles, involves the internal intercostals, the transversus thoracis, and the abdominal muscles. Ever notice how your stomach and ribs hurt after a couple days of coughing? This is an example of forced expiration. And now, on to the big tracing.